Yeah, welcome to another video about differentiation optimization. It's just a few more questions to make sure that it's easy to understand the same sorts of steps. Each time these are the sorts of things we need to be doing. Look for a constraint. So in the question it will say something like the surface area equals 100, the volume equals 50, the length equals 20. There will always be a constraint in some way, and write an equation to satisfy that constraint. So if it tells you the volume of a cube is 20, x cubed would be 20, for example. Also, look for what they want as the final answer. If it's asking for max volume, write an equation for volume. If it finds minimum surface area, write an equation for surface area, and so on. You're going to rearrange your constraint equation and substitute it into equation 2 and differentiate, and then answer the other questions. But essentially they're the key 4 steps that you need to be looking at. So it's got a closed cylinder, radius r, height h. The surface area is 192 pi. So there's my constraint. Remember we were talking about a constraint a minute ago. So the constraint here is surface area. So the surface area of a cylinder, the surface area is 2 pi r squared plus 2 pi r h. And we know that that is equal to 192 pi. The second constraint, the second equation that I need, it's asked me to find the volume. So I need to think about the volume of a cylinder. So that's pi r squared h. Now if I look at this, my extra variable that's getting in the way is h. So if I think about my area one, 2 pi r squared plus pi r h plus 192 pi, I want to rearrange that so it's in terms of h, so I can eliminate it, so I can get rid of it. Now to make things easier, I'm just going to divide through by 2 pi. So divide each individual bit by 2 pi, so we get r squared plus rh equals 96. So h is 96 minus r squared over r. Now if we go back to our volume, because I need it to look like this is what the question has asked me to do, to find the volume. So v equals pi r squared h. Now instead of h, I can substitute 96 minus r squared over r, because it's the same. H is worth the same as 96 minus r squared over r. So I'm not changing anything. If I just multiply it out, I'll make it look like what it needs to in the question. So look, I've got 96 pi r squared over r minus pi r to the 4 over r. And I can cancel some r's here, so I get 96 pi r minus pi r cubed as required. Now from here, it really is just a case of playing with it. So find a value of r which is stationary. So I'm going to find dv dr, which is 96 pi minus 3 pi r squared. And because it's stationary, that's going to equal 0. So 96 pi equals 3 pi r squared. So if I divide through by 3 pi, r squared is equal to 32. So r is root 32, which is the same as 4 root 2. So then from there, to calculate the maximum volume of V, I'm just going to substitute this value of r I found into my volume equation. So V equals 96 pi 4 root 2 squared minus pi 4 root 2 cubed, which is 256 pi root 2, which is about the same as 1137. Okay, so we'll look for the constraint again. The surface area is 360, so that's the one that I need to be using. Now it's an open top cylinder this time, so it's just pi r squared plus 2 pi r h is equal to 360. Again, it's asked me to find volume. So the volume is pi r squared h. Obviously the volume isn't affected by it being an open top. So we'll rearrange that first equation. I get to make h the subject. So 360 minus pi r squared over 2 pi r is equal to h. And then I can substitute that into the volume equation. So the volume is pi r squared 360 minus pi r squared over 2 pi r Now, it might be easier to do some cancelling before we start. So those pi's can cancel, and one of those r's can cancel. So I'm getting r 360 minus pi r squared over 2. It's good that I've got the over 2, because I've got if I look up here, I've got a half. So I get 360 r over 2 minus pi r cubed over 2, which is 180 r minus a half pi r cubed as required. And from there, as before, I'm just going to find dv dr, which is 180 minus 3 over 2 pi r squared, and that equals 0. So 180 equals 3 over 2 pi r squared. So pi r squared is 120, r is 120 over pi square rooted, which is about the same as 6.18. So I'm then going to substitute that to find the maximum volume. I'm going to substitute it into my volume equation. So the maximum volume is 180 times my answer minus a half pi my answer cubed, which comes out as 742. Now, I know in these questions we've got some other bits show that it's a minimum or maximum, for example. Remember, you can use your calculator to do that. You can draw a picture, you can find the differential just either side of the point. I hope that helps. Thanks very much.